Objective A, factor a trinomial of the form ax squared plus bx plus c, where a is 1. This form is a general form of the quadratic expression, and when a is 1, it's the easiest form to factor. So let's start with the easy ones. Number 1, x squared plus 9x plus 20 equals, and it's asking you to find the missing factor. One of the factor is x plus 4. They want you to find out what the other factor is. So let's do the long way to figure out how it works. So what I'm gonna do is I'm gonna write this as x plus, let's say, b. Actually, let's use a different variable. Let's do x plus e. Let's do e. Why do I do e? Is because we are going to do the reverse engineering. We're gonna do the FOIL and see what happens on the right hand side if I do the FOIL. So what you're gonna do is you're gonna have x times e, 4 times x, and 4 times e. So let's write it out. X times x, that's x squared. X times e, so I'm gonna write as plus ex. And then you have 4 times x, that is 4x. And then finally you have 4 times e, that's 4 times e. And then I'm going to combine like terms. So x squared plus the middle two terms, both of them have x, so they're like terms. Add the coefficients, e plus 4 times x. And then plus 4 times e. Plus 4 times e. So why do I do that? Because we have the general quadratic form on the left hand side, so we could actually put them side by side and compare. Let me highlight the similar parts. First, the first term, both of them are x squared, so there's nothing interesting. But the second term, on the left hand side, you have positive 9x. Let me adjust this. You have positive 9x. On the right hand side, you have positive e plus 4x. That's something common. So basically what that says is we have 9 equals e plus 4. Then let's look at the last term on each side. On the left hand side, you have positive 20. On the right hand side, you have positive 4 times e. Positive 4 times e. What that means is we have 20 equals 4 times e. We have two equations, but only one variable. The variable e has to satisfy both equations. And there is only one answer that will make it work. You probably know that already. It has to be 5. Because, 5 plus 4 gives you 9. 4 times 5 gives you 20. So that's how you determine the missing factor from number 1, just by using FOIL. And the purpose of this exercise is to give you an idea of how you could factor quadratic forms like this. So I'm going to introduce you to a method that personally I like a lot. It applies to any kind of quadratic general form. As long as it's factorable, then you could apply this method to do it. It doesn't matter if the coefficient of the highest degree x squared is 1 or not 1. It will work for both cases. So let's use number 3 to illustrate this method. Under x squared, you're going to put down the two factors such that when you multiply, that's going to give you x squared. In this case, we only have one choice, x and x, because x times x gives you x squared. And then under 15, you're going to do the same thing. So come up with two numbers such that when you multiply, you get 15. So I'm going to give you a pair that will not work because I want to illustrate how you could check whether or not the numbers that you made were the correct one. So I'm going to do 1 and 15 here. Notice that 1 times 15 gives you 15. And then how do you check if your answer is correct? So you're going to do a cross multiplication. Do a cross multiplication and then add them up. X times 15, that's 15x. And then you do x times y, that's 1x. If you add them up, we will obtain 16x. So notice that this 16x is not the same as what we want, which is the term in the middle. The term in the middle is positive ax. They do not agree. That means our choice is incorrect. I call this method the educated guess method. Educated guess means you're not just randomly guess, you're actually picking up numbers that satisfy certain requirements. Based on our guess, it doesn't work. So that means we have to retry it. So let's retry it. I'm gonna move this to the left hand side. So I'm gonna keep this right here just in case you need to look at it as a reference. But we're gonna start a new guess. Let me put it in red. In green. Under x squared, I have x and x. Under 15, so this time instead of doing 1 and 15, we could do other choices like 3 and 5. Let's do 3 and 5 because 3 times 5 also gives you 15. Cross multiplication. Let's check. X times 5, that's 5x. X times 3, that's 3x. When we add them together, we obtain ax. Is ax what we want? Yes, right? Because in the middle, what we want is ax, and we do get ax. So it's agreed. They agree with each other, and that's our choice. And here is the question: how do you write your factor full? Because this is just educated guess. It's the work. What you're gonna do is you're gonna look at your table that you created horizontally. So I'm going to look at it horizontally. First one is x and 3. Second one, x and 5. So what you're going to write is, you're going to write equals, put two pairs of grouping symbols. It's going to be two factors. The first factor is the first row, which says x and 3. Because 3 is positive, you're going to put a plus in the middle. If you have a negative number, then it's just going to be a minus sign in the middle. Second factor, you have x and 5. Since 5 is positive, you put a positive in the middle. And that's the factor form for x squared plus ax plus 15. I personally love this method because this method works for almost all cases of general quadratic form that can be factored. It doesn't matter if your a is 1 or not 1. Let's look at another example, number 5. To reinforce this method, under x squared, you're going to put x and x. It's always the case if your first term is x squared, because only x times x give you x squared. And then under the coefficient, the constant term -4, you're going to make an educated guess. So pick up two numbers such that when you multiply, you get -4. You don't have to worry too much about the middle term yet. As a beginner, I would suggest just go with your feeling. As you do more these kind of problems, you will conclude yourself what kind of number that you're going to pick, and then you could make educated guess really fast. So if at the beginning you find it frustrating, don't get discouraged. Everyone goes through that stage. Under -4, so let's say -4 and 1. Right, because they're negative. The product is negative, that means one of them must be negative, the other one is positive. -4 times 1, that gives you -4. Let's check by doing cross multiplication. X times 1, that's 1x. And then x times -4, that's -4x. And if you look at it, it's already an expression, 1x minus 4x, which is -3x. Notice that it's not exactly what we want, right? We want positive 3x, but what we got is -3x. If that happens, don't get discouraged. You actually should feel happy. Why? Because you're close. So I'm gonna move this to the left hand side. Let's move it to the right hand side. It doesn't work. I'm gonna put it over here. If it doesn't work, then you're gonna try other choices. Under x and x, under x squared, I'm still gonna put x and x. Under -4, what number should you try this time? So notice that we got negative 3x, not positive 3x. Therefore, all you need to do is change the signs. Originally, we picked negative 4 and positive 1. If you change the sign, what's going to happen? So let's find out. I'm going to put positive 4 and negative 1 right here. So notice that I didn't change the order of them. I only changed the sign. It's because what we got was the opposite sign of what we want. Now let's do cross multiplication and check. X times negative 1, that's negative 1x. X times 4, that's positive 4x. And if we add them together, we obtain 3x. Is 3x what we want? Yes, right, it is what we want. So that is our correct guess. Now let's look at them horizontally. X and 4, x and negative 1. And you're going to write the factor form as, put the grouping symbols, and inside you're going to read it horizontally. You have x and 4. Because 4 is positive, so it's just plus 4. And you also have x and negative 1. So you just write x and negative 1. And that's it. This is your factor form. X plus 4 times x minus 1. Of course, you could double check your answer by doing FOIL, and that should give you the original expression, which is x squared plus 3x minus 4. Next page. So if you look at next page, we have plenty of exercises. I highly recommend that you could try this method on your own before you watch what I do. There are some special questions on this page that may require your attention, but let's look at them. Number 7, x squared plus 2x plus 4. This problem is a little bit special. If you tried it before you watch me doing this, you'll probably notice that no matter what number you try, no combination is going to work. So it doesn't matter what you try under 4. Once you do the cross multiplication, it's impossible to get positive 2x as the result. We call this kind of quadratic expression prime. It's just like how prime number works. So this one, you cannot factor it. It's just like how prime numbers, you cannot factor it. Like 3. You could not break it into two numbers multiplying that gets you 3 other than 3 times 1. This is the only way that you can do. Not like 15, right? 15 is not a prime number because we could break it into 3 times 5. So for this expression, we have no way of breaking it into algebraic expression multiplied by another algebraic expression. We can only do the original expression multiplied by 1. So this is a prime. We cannot factor it. Number 9. 14 minus 13x minus x squared. This one, I highly recommend that when you factor it, you want to make sure that it's in descending orders. This algebraic expression, it's not in descending orders. The highest degree is in the last term. So this is actually in ascending orders. What I'm going to do is I'm going to take out a negative 1 and rewrite the original terms. If I take out negative 1 or just take out negative sign, you basically reverse the sign of everything inside. So positive 14 becomes negative 14. Negative 13x becomes positive 13x. Negative x squared becomes positive x squared. And then I'm going to rewrite what's inside in descending order. First term, x squared. Next term, positive 13x. Next term, negative 14. And now we are ready to factor. Under x squared, there's only one choice, x and x. Under negative 14, if you make educated guess, you will notice that the only combination that works is positive 14 and negative 1. So let's actually check by doing cross multiplication. X times negative 1, that's negative 1x. X times positive 14, that's positive 14x. If you add these two, you get 13x. 13x is exactly what we want in the middle. So this is correct. We write our final answer horizontally. Therefore, we conclude our final answer is x and 14. Put a plus in the middle because 14 is positive. And then you also have x and -1. And that completes your factor, which is x plus 14 times x minus 1. Number 11. X squared plus 14x plus 49. So it's the same idea. Under x squared, we have x and x. Under 49, so you could try different combinations. There are 1 and 49, 7 and 7. By looking at the one in the middle, it's 14. So I'm going to try 7 and 7. Cross multiplication to verify. X times 7, that's 7x. X times 7, that's also 7x. So it's positive. Add them together, you get 14x. 14x happens to be what we want in the middle. So this is correct. Therefore, our factor form is, you write it horizontally, x and 7, x and 7. So that is x plus 7 times x plus 7. This number 11 is basically a perfect square. So later on, we're going to learn a formula that helps you identify perfect squares like this. Number 13. This is already in descending order, and the coefficient of x squared is positive 1. So we can go straight to the educated guess stage. Under x squared, you have x and x. Under negative 26, so here's where you have to guess. So I highly recommend that you pause the video and think about two numbers such that when you multiply, that's going to give you negative 26. And when you add them, do the cross multiplication, it's going to give you 11x. Alright, hopefully you find the right combination. If you didn't, then you should check whether or not you thought about these two numbers. Positive 13 and negative 2. And by the way, the order doesn't matter. You could also change it to negative 2 and 13. As long as when you do the cross multiplication, you get positive 11x. So let's do the cross multiplication. X times negative 2, that's negative 2x. X times positive 13, that's positive 13x. If we add these two, we obtain 11x. And that's exactly what we want in the middle. So this is the right educated guess. Therefore, we write it horizontally. X and 13, x and negative 2. So x and 13. 13 is positive, so you put a plus in the middle. And then you have x and negative 2. And that completes your factor, x plus 13 times x minus 2. Number 15 is a little bit special because this time we have two variables. Instead of just having one variable x, we have two variables. Don't panic, it's very similar to what we just did. So you could apply exactly the same method that you have been doing. Under x squared, we're gonna have our only choice, x and x. And now under negative 12y squared, instead of just looking at the negative 12, you also have to look at y. So I'm gonna put the y and y first, because y times y gives you y squared. And then you're gonna worry about the negative 12 part. Negative 12, so it's the same as before. You're gonna come up with two numbers such that when you multiply, that's gonna give you negative 12. Notice that in the middle, it's negative. It's a negative xy, which is a negative term. What that means is, let me rewrite the circle. What that means is the two numbers that you pick for negative 12, they have to be add up to negative 1. That's basically what that means. And the only way to make that happen is if you do negative 4 and positive 3. And of course, you could switch the order. You could do 3 and negative 4. It doesn't affect the results here. Let's do cross multiplication to verify. X times 3y, that will give you 3xy. X times negative 4y, that's going to give you negative 4xy. Let's add these two together. 3xy minus 4xy, that's negative 1xy. Or it's the same as negative xy. Is this what we want? Yes, it is what we want. If you get positive xy, that means you're close. You only need to switch the signs. And then we're going to write our factor form. So remember, you only need to write it horizontally. X minus 4y, x plus 3y. And that is the factor form for number 15. Number 17 is also very interesting. If you look at number 17, the coefficient of your highest degree is not 1. What is that coefficient? Is it 10? No, it's not 10, right? If you say it's 10, that means you didn't look at the degrees. The highest degree is actually the second term. It's not the first term. So what I'm going to do first is I'm going to rewrite the terms in descending order. The second term has the highest degree, so I'm going to write it first. Negative 2x squared. Notice that the coefficient of x squared is not 1, it's negative 2. And then the next degree is 10x, first degree, followed by the constant term, positive 12. So this is the rearrangement using commutative property of addition, writing in descending order. And then this is very similar to number 9, where we took out a negative 1. So here, what we're going to do is we're going to take our GCF between among all these three terms. If you look at the coefficients, you have negative 2, you have positive 10, and you also have 12. The greatest common factor between these three is negative 2. You could do a tree or you could just look at it. Once you take out a negative 2, you could figure out what's left. Do a simple division. First term, negative 2x squared divided by negative 2, that is simply x squared. And then positive 10x divided by negative 2, that's negative 5x. And then finally, positive 12 divided by negative 2, that is negative 6. So you have to watch out for the signs here. You have a lot of negative going on. Make sure you double check before you continue. And now we have this form, negative 2 times a quadratic general form whose coefficient of the highest degree is 1. So what I'm going to do is I'm going to do the educated guess. Under x squared, you have x and x. Under negative 6, you're going to come up with two numbers such that when you multiply, you get negative 6. So here, I'm going to save you some time. After several tries, you will find out that the pair that works is negative 6 and positive 1. So let's actually verify it. X times 1, that's 1x. X times negative 6, that's negative 6x. 1x minus 6x, that is negative 5x. And it happens to be what we need in the middle, which is also negative 5x. So our educated guess is correct at this point. And then we're going to continue our factor form because that's not the final answer yet. So what you're going to do is first, you're going to drop the negative 2. So notice that you have the negative 2 in the front. You cannot ignore that. And then followed by two pair parentheses. That's the factor form for the quadratic form inside the original pair of grouping symbol. And you're going to read it horizontally from our table. X minus 6, x plus 1. X minus 6, x plus 1. And that completes the factor for number 17. Moving on to next page, we have two more problems. Number 19. Number 19, some people might say, first of all, it's not in descending order, even though the first one is x squared, but we have a term that has third degree. So we're going to put it in descending order first. X cubed plus 10x squared plus 16x. So that'll be the first thing to do. And then second thing, this is actually a general rule. First, put in descending orders. And second, we're going to factor out GCF. Looking at these three terms, all of these have at least one x. So we're going to take out the x. As for the coefficients, the GCF is 1. So we don't really take out any numbers, but we do take out a variable x. Once we take out this GCF, you're going to write down what's left. So do a simple division. x cubed divided by x, that is x squared. Positive 10x squared divided by x, that's positive 10x. And finally, positive 16x divided by x, that is positive 16. And now you see we do have a general form of a quadratic expression inside that pair of grouping symbol. Then we're going to do the educated guess, x and x under x squared. And then under 16, here's where you have to guess. So I think most of you guys should be able to guess during the first trial, because the most common way to get 16 is if you do 2 times 8. Now let's check by doing cross multiplication. X times 8, that gives you ax. X times 2, that gives you positive 2x. Ax plus 2x, indeed, it is 10x. And that is what we want in the middle. So this is correct. Then we write our final factor form. When you write the factor form, copy the factor outside, which is x. And then for the grouping symbol inside, you're going to put 2 pair of grouping symbols. And then read it horizontally. So you have x and 2, you have x and 8. And x and 2, put a plus in the middle because 2 is positive. X and 8, put a plus in the middle because 8 is positive. And that completes your factor form for number 19. Number 21. AB cubed plus 6AB squared minus 40AB. This one is kind of like the ultimate example of what we have been doing for factor trinomial. First thing to do is factor out GCF if you can. Just remember that, always do that. We are in descending orders, so we could go ahead and factor out GCF. By looking at these 3 terms, all of them have A. So write an A first. All of them have at least one B, so write a B as well. As for the coefficients, you have 1, 6, and negative 40. GCF is 1, so we cannot take out anything. Now divide the original by AB. First term becomes B squared, followed by 6B, and then you have minus 40. And again, what's inside the grouping symbol is a general form of a quadratic expression. That means we're going to do educated guess. Under b squared, you only have one choice to get b squared, that is b times b. Under negative 40, you're going to pick 2 numbers such that when you multiply, you get negative 40. Since the product is negative, one of them has to be positive, the other one has to be negative. So pause this video if you want to give yourself a try, see if you could actually come up with the correct combination. Make sure you do cross multiplication to verify, and your goal is to get positive 6b. Hopefully you got the right combination, and the combination that I got is negative 4 and positive 10. Negative 4 times positive 10 is negative 40. And when I do the cross multiplication, I obtain 10b minus 4b, which is indeed 6b. Therefore, I write my factor form. So first, you're going to drop the ab outside. You have ab. And then you have 2 pairs of grouping symbols. Read the table horizontally. You have b minus 4 and b plus 10. And that completes the factor form for number 21. Number 23. Show that for any whole number n, the number represented by 4n squared plus 28n plus 48 can be expressed as the product of 2 consecutive even numbers. So that's basically asking you to factor this expression and then see that they are the product of 2 consecutive even numbers. So let's do that. 4n squared plus 28n plus 48. So what I'm gonna do is I'm gonna start guessing right away. Even though you might know that we could actually take out a GCF, which is 4. But I'm gonna go straight to the guessing because later on, if you factor out 4 first, you will notice that you have to actually distribute that 4 again into the grouping symbols. To avoid that step, I'm just going to go straight to the guessing. Under 4n squared, you're going to come up with two numbers such that when they multiply, they get 4n squared. So here, I'm going to give you the combination, which is 2n and 2n. 2n times 2n, that gives you 4n squared. Under 48, you're going to come up with two numbers such that when you multiply, you get 48. And I would say if you remember the multiplication table, the straightforward way to get 48 is 6 times 8. So let's give this a try. Cross multiplication. 2n times 8, that's 16n. 2n times 6, that's positive 12n. 60n plus 12n, that is 20n. And it is what we want, right? We want 28n in the middle. So that's the correct combination. Therefore, we factored the original expression, the original trinomial, into the product of two binomials. You read it horizontally, 2n and 6, 2n and 8. So you write them down, 2n and 6, 2n and 8. Both of the numbers are positive, so you put a plus in the middle. And that's 2n plus 6 and 2n plus 8. And you basically complete this problem already because 2n plus 6 and 2n plus 8, they are two consecutive even numbers. First of all, how do you know they're even? Because they have a factor of 2. 2n and 6, you could factor out 2. 2n and 8, you could factor out 2. So both of these numbers are divisible by 2, therefore they're even. And then, how do you know they're consecutive? Well, check out the difference between them. 2n and 6, 2n plus 8, they have a difference of 2. Any consecutive even numbers should have a difference of 2, like 2, 4, 6, 8. If you checked out the difference, it's just 2, right? That's how you know that they are consecutive even numbers. All right, that completes this homework. Thanks for watching.